Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about in server system architecture. That is, what is in server system and what are the parts of the server system, that is in transaction server and data server. We will discuss each of the transaction servers and the data servers, and finally we will know what is in cloud-based server. The server system architecture is based on the concept that there is a finite and central system which serves as the server part to the clients. Now it is more like this centralized server system, not a centralized client server architecture, which is different from it. Now the server system, that means there are facility survivors or service providers that we are having in this architecture. So it can be two types. One is in transaction server, another is in data server. The transaction servers are the server over which we can provide from the client side the transactions or the queries. It is often known as a query server too. Now this query server or the transaction server serves the query that is provided by the client and gives back the result of this transaction or the queries to the client. Now the queries can be done by this SQL or any other transaction mode that it can keep track of every log records, the transactional records, and all the database that is needed to transform this transaction that fetch the data from this query. Now this is all about the transaction server. Now what is a data server? When a client directly needs to read, update the data from the server side. That means it is not querying on a platform. It is just sending messages to the server that we need the direct data from you. So this type of server is known as data server, where it can provide the facility to read, update, or modify the data by the client side by this type of server. Say for the instance, the file type system server, which provides the access to the files, but the data servers are most importantly larger than these file servers, because not only it serves to the files, but also it serves to each of the object like the tuple or any other item on it. So now first we will discuss about the transaction servers. The transaction servers, as we have prescribed, that it provides us with the transactions to be completed by a central server which provides the query and then solves the query of each of the clients that is connected to it. Now there are many other processes that is connected to a transaction server. We will discuss one by one on each of the process. Now the first and foremost process that is connected to a transaction server, that is in server process. A process is a single unit which can perform a particular task on that predefined program. Now the program can be subdivided into processes, and that each server is having a lots and tons of work to it, so it divides the task into different type of processes. That each of the processes now become my server process, and every process will serve different parts of this task. Now the server process is even connected with this data server with the JDBC or the Java database connectivity or the Open Database connectivity, so that it can embed itself with the SQL queries and then connect to the database from this SQL queries, which will be solved by these server processes. Now the server processes are divided into thread. Now the thread are the processes are always like same, but the threads are very lightweight, are also called as LWP, lightweight processes on this thread. Now as the thread is considered to be the part of this processes, now all they belong to their parent process at the same time, where they can have their own implementation. So it is not a burden for the process that the thread is having, and also the advantage that the thread can connect more smoothly with other threads belonging to the same process. That means now we are subdividing our task of one process into threads. So the server process belongs in this way. Now the next process is a user process. So to which the server process with the connectivity that it connects to. That means the server process is actually serving some task. Now the user processes are the process which asks for the client information to the server process. That means it asks for a task to be done, and that the server process connect with the JDBC and ODBC with the user process, which will be solved the result and then give them back to this user process. Next come with the shared memory that the server process and all the server process are sharing. That means it is the memory of this server or any transaction server. Now the transaction server shared memory is generally associated with two processes. One is the process manager one, another is a log writer process. So the process monitor process actually monitors all the status of different processes. That means to which process it is belonging, to which data it is mining, it is strict capping of this particular processes. Now the log table manager or the log manager process keeps track of all the lags that is granted on every process or every database. That means which type of log it is having, what log it is having, and to which the log is granted. So all the table is maintained in this log manager processes. Next is the database writer process. Database writer process that it writes the data that from the database end to the server process. That means it fetches the data from the database, write it to the server memory, and also the update on this database server it gives back to the databases. Now the next one is a log writer process. The log writer process keeps track of all the transactions and then perform a log on it, and also it holds on this log that is not made to this stable storage. That means it writes the log and it is the process on the task of doing the log writing. Next process is checkpoint processes. The checkpoint process keeps a checkpoint at an immediate or a fixed interval of time so that if there is any problem in the transactions that it is facing by the server, then it can roll back the transaction to the last checkpoint and start from that checkpoint, not the beginning of the transactions. So these are the processes that is associated within transaction server. Next is the shared memory that the server can access. Now the shared memory can contain this log buffer, buffer pool, log manager, and also the shared memory. First is the buffer pool. So the buffer pool type of shared memory actually keeps tracks of all the buffers. That means what are the log buffers, the log buffers, and also the query cache buffers. So all are put into this buffer pool first, and then it can access from this buffer pool over a particular data on an access. The next is the log buffer. The log buffer keeps track of all the buffer that is providing a log to a cache memory. That means if the log is being granted to a memory but it has not been started for that process yet, then it will be kept in this log buffer. Next is the log buffer. The log buffer keeps track of all the logs that has been made by the transaction, but it is not put to the stable storage till now. That means the log has been performed, but the updation is remaining. And the last type of shared memory is in query plan cache. This type of cache or buffer takes care of the query that has been already served but still remains in the buffer. So it is remaining in the buffer for some future use. Say for one query is querying again and again from a particular client. Then we must store it into the query plan cache so that we can solve and serve to the query faster than if it is fetched again from the client side on the later one. Now this is a basic structure that we can see on a transaction server system. All the processes, there is a shared memory, and the database writer process, the log writer process can access to the actual databases. Now that we can know that every process is belonging to its different situation, then to provide this mutual exclusion, we must provide the servition of this deadlock. Because the process, there can be a situation that one process is waiting for other process to be served. So there is a deadlock situation which can arise when in a transaction being a server. So if we provide the mutual exclusion, that means if it is in a critical section or a particular section of the shared memory which is acquired by a different process, now it can be acquired by another process after the process that is acquiring it has released that particular portion. Other than in any situation, no processes can enter this type of memory or the critical memory at this point. So this mutual exclusion is extremely important for handling the deadlocks or preventing from the deadlocks. Now some database server or this transaction server uses the different from the mutual exclusion, that it uses an atomic transaction. That means if the transactions are atomic in nature, that means all the operations will be grouped together and they will be performed at a whole. That means if there is a transactional operation that has been performed partially, we will not consider the transaction be committed. So if there are many transactions, then we will consider each of the transaction as atomic. Now we can reduce the overhead of having mutual exclusion because the transaction are itself atomic. No transaction can enter while one transaction is performing. So in this way, the mutual exclusion and atomic transaction goes hand in hand with each other. The next type of problem that we faced in this transaction server is that whether the transaction has been completed or not to present it to the client. Now, while to present it to the client, we must pass this message to the client that is the transaction has been occurred, or we can say that the message to be passed if the mutual exclusion used, that a particular data is now locked and it cannot be used by another process. So now other than doing an overhead of keeping message passing, what is the overhead of keeping message passing? Because if we pass the messages, it needs to be packed up like the switches and then packets, and then we can send the messages. It can go and receive in a different order, which is not the order on a query or a transaction where the ordering of the operations is extremely important. So rather we choose a log-based table or a log table manager which keeps track of all the logs that is associated with a particular data. Now if the shared log of data that is associated with an data table or this data transaction server, then there is no other transaction or process that can attach with this type of log with this. Now if it is in shared log, then other process can shared log an exclusive log, then other process cannot do any shared or exclusive log on that particular data item. So the log table becomes extremely important for which to granting a log and for which to rejecting a log. That means if a log is available on a particular process, then the other process must wait or must grant it a log until and unless the log is released by that particular process. Now sometimes we use this log-based release and granting of logs other than using the message passing, but with significant differences. That when we are having this log table manager, then we must support the mutual exclusion. That is not in the case of the atomic transaction. Why we are saying this? Because the mutual exclusion only can support that the processes are not being used for a particular part of data simultaneously. So that granting and releasing of log on this type of scenario can be the main difference of the message passing with this log rest and release. Now the second one, which is more important, that is when we are keeping a log on a particular data item, then how the other process will keep to know that the log has been granted or being released by that data item. So we must monitor the log table to keep track of which process has been given which log and what time they have been given the log. To keep track of all the data that the process is having this log for this much time, so have an idea that my process will be served for a server or not. By repeated checking on this monitor or the logs table, we can avoid it by doing a semaphore usage. While the semaphore, what we can do, that we can wait for a log other than repeatedly checking the log table that the check has been released or not. So using the semaphore, we will now describe that how you can provide it while solving the log mechanism. Now semaphore is a variable, say S, which is granted with two of the operation. One is swait, another is slock. So whenever it is swait, that means some other process has been using that particular data item which is mutually excluded from my process, and now the process can only access that data item, so that my semaphore s.wait is being true. Now when the s.wait or this s.release will be there, then we do not need to check that whether the clock is released by the other item or not. If it is released by the process, then the semaphore will automatically gain access to it because it is waiting for that particular log to be released. Next, we will go to our next part, that is in data server. So after we know that what is in transaction server, what are the process that is associated within transaction server, a data server is more concerned with the data that we can accommodate and accumulate and also update from a client side to the server side. That means it is the warehouse of the data where from the client can query fetch on this database. Now the clients are using this data server as an inherent part of the server system architecture, because the server becomes the source of data or the database for an enterprise and all the clients that is associated with this enterprise. Now we can say that the data servers are used and not only for the mutual exclusion but also for the log-based manager, that for each type of transaction on the data that we are having. Here the transaction doesn't mean that the client is transaction processing with the data. It is the transaction of having read or update the data. Now the data server keeps track of all of this server using this query processor and also the reading and update processing on the data. Now it must supported by this database server to prove the full backend functionality where it can ship the data to the client side from the server side. Now this type of architecture is mainly implemented in the object-oriented designing, where we are not concerned with the transactions but more concerned with the item of a particular database. Now when we are talking about the issues that we can solve with the data server, the first one is page shipping versus item shipping. Where we can provide the page shipping, in this page type of shipping we are actually shipping from the server side to the client side a set of pages. That means the page can be containing a file, the tuples, or a set of tuples, or a set of objects. Now while in the item shipping, the item term refers to both the tuples and an object. Now it is more of a finer granularity, where pages and coarser granularity. So now we can ship these items on demand of the client. That means on difference with the page shipping, that requires a lesser number of message passing, because we are shipping the page because it is prefetching. That means we are sending some of the items with this pre-page that will not need by that particular time, but it finds it relevant to the information that it can find in the later time. This much pre-processing type of information requires a lesser number of message passing, because all the messages are composed together inside a mail, and now the page can be sent through this client side from the server side. So now what we can say, that for item shipping, we can only require the item or the object or the tuple and then send it to the client. Whenever there will be a request for the client to update that particular tuple, we will resend it back to the client on that time. We will not just give all the information of a tuple or a relation as in pre-processing. So the page item shipping is a type of this particular type on which we can pre-process the data. That means we are sending a relevant type of information we may be need by the client side at the later time. Next is this adaptive log granularity. Now when we are talking about a log granularity, that means when the page shipping and item shipping, take this consideration again. For the page shipping, there are many pages, that means there are many information inside these pages. Maybe we will need some or one of the information at that particular time. But as in coarser granularity, we are having a log on the entire page, not just on a single item. Now we are having an exclusive lock on a page that requires the information to be stored in it, and every information get locked on an exclusive mode for that page. Now suppose that another client requires the same type of information that belongs to the page which has been shipped to this particular client. Now at that point of time, then what happens, even if the information that is not required by this client but which is required by another client at an instant of time, we cannot give it because the page is containing an exclusive mode lock. But for item shipping, we can mode an exclusive lock on a particular item, the tuple or an object for that. Now this is known as an adaptive locking, that whenever we can shift from this item locking to the page locking and also the page locking to the item locking. That means based on the demand of the client, we can toggle between these two locking. That is known as an adaptive nature. So which is also provided the name as a dynamic locking, because if the client now works with an item more than a page, then it can changes the exclusive mode lock from pages to the items at once. So this type of de-escalating, that means from exclusive mode lock from pages we are going to the items. So we are actually finer granularity, that means we are de-escalating the types of locks. Now what is known as lock cache, that is requested and related to this adaptive log granularity. Now when we are having a lock cache, that means after the lock is granted to a process for a particular data on the client side to get update it on an exclusive mode lock or get read it on shared mode lock. Now after the lock has been released by this particular item for the process, so what happens, the lock doesn't get immediately released from the server side. It just keeps the lock in the data server in a lock cache. So the lock cache keeps tracks of all the locks that has been allocated to a process from the client side for a particular data item. What is the benefit of having such lock cache? Because say that a client is having a repeated number of time a lock on a particular data item, or say for a set of data item, then if it belongs to the lock cache, then we can easily find that what lock it wants on data based on this heuristic. Say for an instant that for a student who is being inclined to the university, who will always try to mode and shared lock on an university page. That means he wants to read frequently the data from the user side. Whereas if it is the user as a teacher to the university page, then it will be modified for the exclusive mode lock where updation is made, like the changing of classes, changing of classrooms in this. So this lock cache, if can be maintained for each of the client to the data server, then it will be extremely benefit and it will be maintained by this data server for this lock cache. The next one is data cache. Just like the lock cache, if some data that is being fetched by a client and it is being done repeatedly, then it will be not deleted immediately the client loses the lock on it or releases the lock on that particular data item. It just kept in this data cache. But also the data cache, as it improves, that the data on this cache will need less computation time, but we need to take care of cache coherency, which can be a major problem while storing this cache. What is an cache coherency? Say for an instance that the data that is being fetched by a particular client on an update has been put into the cache. Now the relation on which the data is staying has been updated by the server itself, but the data on that relation that is updated by the server, which is residing in the cache, that version is not updated because the data has been already fetched by the client and the cache is storing the fetched data from the client. So what happens, there is a cache coherency. So it will become loose coherent because the data that is updated is not the data that is stored into the cache. So we need to provide an cache maintenance or a view maintenance so that we can keep track of all the updates that is being made to the relation, then also to the cache to maintain the cache coherency. Now this is all for the database server. The next one that we will discuss is the cloud-based server. So what is a cloud-based server? First, we need to know that we are always adopting a third-party agency for a larger company to store our database. Now when we are having this third-party agency, because sometimes it becomes extremely wise to have a third party to store the database, because my large database is not useful for having all the purpose solving. So now we can add to this third party a number of databases. From time to time need to keep it update, and that third party is not in hardware software, it is in software based logic that is known as a cloud. So a cloud is an online service that we can provide to any large companies or even to the personal clients who can store the data of their database into this cloud in an online basis. Now, whenever they want to access from a device, there is no problem that whether to which operating system it belonging, to which schema is belonging, the cloud, which is a unified schema that it have on the server side system. Now, the cloud-based servers gives us the facility that whenever we want to add a data or a particular machine to this cloud, we can just add it to the cloud by adding the machine to that particular cloud-based server. Now, what happens if there is a machine that wants to remove the data from the cloud? It is as easiest as the insertion of the machine. Now the cloud can contain many of the machines on demand, on which if we can add it or delete it from the server. So now the cloud server serves as a cloud-based server to all the clients or the servers which are using that cloud server as a third party. See, the cloud server can be the server to the server of the client. That means the server system architecture. So it is now going in popular trend nowadays because it can provide an unlimited storage, because there is no physical storage to which we are attaching the cloud. It is just like the cloud which can grow on size, shrink on size depending on the demand. So that is all for the server system architecture. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.